Hello again, welcome back. Here is a new set of videos about differentiations. We're going to start with differentiation rules part 1, and in the next video I will do the second part to this where I will be focusing on the rule number 3 and number 4 for differentiation. So let's get into it. So first example, here is the uh, volume example we have. The function VR is 4/3 pi times r cubed. We want to do the first derivative of this function, the volume function, and what we're going to use, the typical differentiation rule, and number 1 is going to be the first one that we're going to use. Now notice that I've got 5 rules written up here for us to remember, and if you don't need to remember it, but you do need to know how to use them. Okay, that's what we're going to do. So let's start. So 4/3, the first thing you have to notice that 4/3 pi, that's a constant. So that nothing happens to that. So the v prime of r equals to 4/3 pi is unchanged, and then you have to use the differentiation rule where you bring the power down, so 3, and then the variable, and then the exponent minus 1. So 3 minus 1 is 2. And rewrite. So when you rewrite, now you can simplify. 3 divided by 3, that's 1. So you will get 4 pi r squared. That is v prime of r. Okay, so that is the first derivative of this volume function. Now let's look at the second question. The second question is this one. This one is a function given root x minus 1 over root x, and we want to find the f prime of x, which is the first derivative. All right, so we have to go through a couple of ways of doing this question, but I suggest you just first simplify this function as much as you can so that it makes it easy for yourself. So remember, in differentiation, exponents are the key to make sure that you're doing the derivative correctly. So let's change everything. The original f of x, we're just going to change everything into the exponent form from the radical form. And this 1 over root x is x to the negative 1/2. It's basically the same as root x, but because of its reciprocal, you have to bring the denominator to the top, and then you have to change the sign of the exponent. So that's what you have. All right, now let's go through the derivative. And the rule says 1/2 comes to the front, x, and then 1/2 subtract away from 1, so that would be negative 1/2. So that's the derivative of the first term, which is right here. So that's the derivative of first term right there. Minus, now we're going to do the same thing. Open the bracket, negative 1/2, the exponent comes to the front, x, and then negative 1/2, and then subtract 1 again. So that would be negative 3 over 2. Very good. Now, let's simplify. You always have to simplify. What you will have is 1/2 x to the negative 1/2. Now here is plus 1/2 x to the negative 3/2. Very good. Now you can leave this alone and say you're done. But sometimes you need to change the negative exponents to positive exponents, especially if your professor or your instructor is asking you to do that, to make sure that you know what to do. So let's rewrite this using, we're going to change it back to the radical form. So this would be 1 over 2 root x. So that's the first term right there. This is the first term right there. Okay, so 1 over 2 is 1 over 2. And then this exponent negative 1/2 drops down to the denominator, and 1/2 is a square root. Remember that. You're changing radical form to exponential form and vice versa. Plus and then we do the same thing, 1 over 2. Now this time you have to remember how this form, exponential form, changes into the radical form. N is the root, the index, and then x goes inside, and m is the exponent of the argument inside of the radicals, which is called the radicand. Okay, so here it is. That's what we're going to employ here. So x will be here, 2 will be here, but we don't write 2. It's a square root, but so we don't do that. It's the same as what we don't do there. Okay, so these two, which you can leave it alone, same as up here. We never put 2 in there because this square root is implied, and then -3 becomes a +3. You can now leave that be, and that would be your final answer. Okay, let's look at the third question. Okay, so here's the third question. We want to solve for the first derivative, and we're going to use basically the very first or second law, I think, the addition subtraction of the functions when you're doing derivative. Right here we're doing f plus or minus g, and then we're going to take the first derivative, and that means that we have to take the derivative of the first function and then plus or minus the g function. Now when I say plus or minus, in this question that I showed you right now, it's the addition, but you could have a subtraction. That's why I put in the plus or minus. We're going to go through, do the derivative for each term. So y prime is equal to, again, now we're going to do it very quickly, -2 times 3 x to the 2. Remember the rule again. So 3 comes to the front, then subtract 1 from, that's what you will get, plus, and then 5 times 2x, and then the -1 derivative, that is, remember, ddx of any constant c, which was the fifth rule, that's just 0. So we don't have to write that. Let's simplify. -6 x squared plus 10x. That is your final answer for the derivative of this function. Okay, I hope you found this useful. If you did, subscribe, like, share this video with your colleagues, your friends, your mom and dad, and come back. When you subscribe, whenever I put up a new video, you will be the first to know. All right, until next time, be well.